Hello everyone. Today we are going to be doing the Unit 3 review packet. I do want to take a second to remind you guys that these videos are not meant to, especially the review videos, are not meant to be teaching you the skill. At this point when you're watching the video, this should all just be review. Now some of the problems, maybe, you're looking at the first ones or something like that, and you're like, I don't remember how to address these. Then you watch this video and hopefully it's more of a refresher that, you look at these first problems and you're like, oh, I don't even know how to do these. And then I show you how to do them and then you're like, oh, that's right, that makes sense, I'm good. So you should already know the processes that I'm doing on here, but rather using these videos to kind of refresh your memory. So again, I'm going to try to go through this as quick as possible, and then we will go from there. Okay, so the first two problems say graph the following systems of equations and write the solution as an x comma y. These are not inequalities, so the ones down below, these ones have the little inequality symbols. You're pretty much going to be doing numbers 1 and 2 the same as you would be doing 15, 16, and 17. The only difference is that these ones get shaded, and then you kind of look for that overlap. But these first ones are just straight up equal signs. So when I'm looking to graph these, you do always have to have these as a y equals. So I'm going to go ahead and bring the 3x over to the other side. Make sure that when you are bringing it over, that you're using the process of subtraction. So I have 3 minus 3, makes that go away. And then that means I'm going to have a minus 3x on the other side, plus 4. And then for the second problem, solving that for y, all I pretty much have to do is bring the 2 over, so 3x, and then I'm going to subtract 2. So these two right here are going to be the equations that I want to graph. And for those of you who are still not really good with graphing, this could maybe be a good opportunity to kind of get to see that one more time. Bear with me, I got to move the camera a little bit. Okay, so when I'm looking to graph these, a reminder that you should start by looking at this value that is attached on the end. That 4 represents your y-intercept, and that's an always thing. That will always be the case, always the y-intercept. So we call it the y-intercept because it will be graphed on the y-axis. If you get the x and the y-axis confused, look really closely at the graphs because they are technically labeled on every single one that I give you. So there's the y, and here's an x. So if you're looking for the y-axis, you should be going to the y-axis and going to the value positive 4. Now, most of you guys proved that you could do that, and again, those of you that struggled with the graphing, a reminder that this value in front of the x is technically going to be your slope. Remember that slope is always rise over run. So when I look at negative 3, that's technically negative 3 over 1. So that means that negative meaning I'm going down, 1, 2, 3, and then positive 1 meaning I'm moving forward 1. You could also rewrite this as 3 over negative 1. Those are the exact same thing. It doesn't really matter where you put the negative sign, but you do only get one negative. So if I look at it this way, my rise would be 3. So that means I'm going up 3. That's positive 3. And then the negative 1 says I'm going back 1. So I'd have to go back 1. And those are going to be kind of all the dots that I need to graph. You really don't only need like 2 or 3 dots, and then you should be able to graph it. I would recommend using a ruler, but I'm kind of lacking a ruler right now, so I'm just going to go ahead and kind of, that was, pretty bad. I should have used a ruler, but it's okay. I don't have a ruler on hand, so. The second part, if I go ahead and do the y-intercept is negative 2, so I'm going to go to negative 2. In this case, my slope is going to be over 3 over 1, so it's always going to be positive over positive. So if I go up 3, 1, 2, 3 over 1, I put a dot there, up 3, 1, 2, 3 over 1. So my graph's going to go something like this. And you'll notice that when I was counting, I hit this dot. Well, this was the same dot that I graphed from this one. I went down 3, forward 1. This one I went up 3, forward 1. So I ended up on the same dot. That will frequently happen, not all the time. We looked at a couple of examples in class when that didn't happen. But most of the time it will end up hitting the same spot. And then you just kind of have to define what that point is. So that is at x equals 1 and y equals 1. So my answer is 1, 1. So I'll kind of give you a good recap there. Number 2, you can do by yourself. Again, answer key is posted on Canvas. These ones down here, like I said, are the graphing inequalities ones. So there's only 2 of these that I want to do, and then I'll leave the middle one for you. So the first one, if we look at the first one here, these are already in that y equals form, which is really nice. I can just go ahead and graph this. So here's my y-intercept at -1. My slope, remember, is going to be what's in front of the x, which is just technically 1 over 1. So if I go ahead and graph that, up 1 over 1, up 1 over 1, and my graph's going to look something like that. Again, you probably want to use a ruler. It gives you a better eyeball. Actually, in my answer key, if you look at this, nice and straight lines, because I did use a ruler. And then the second one, I'm at +2. My slope is still technically 1, 1. You will notice with this one, they're not actually ever going to touch. So if that was the end of this problem, if these were equal signs, like the ones up top here, my answer, little pop quiz I guess you could say, if these were my 2 lines and that was my answer, what would I say if they're never ever going to touch? Well, technically according to up here, I'm looking for the point of intersection where they do touch. But if the graphs never touch, there's never going to be a solution. So if this was it, that would be my answer, no solution. However, this one does talk about shading. So I kind of mentioned this, and I did it in one of my answer keys if you've been kind of checking your homework. But a lot of times when I do shading, I like to kind of color in the problem. So if I try to get that color showing up better. If I color that one green, I'm going to shade that one green. So it says less than this x minus 1. So this is my x minus 1, and it wants less than. So I'm going to go ahead in this direction. Then if I take red, let's say I take red, my second problem here, I'll do in red, and it says greater than, so I'm going to go this way. And then according to inequalities, you're always looking to find your answer in the area that's double shaded, so where there is both red and green. In this case, there is no space that's red and green, so my solution is going to be no solution. Now I do want to take a second to point out that let's say that for some fluke reason I gave you a problem like this. So I took the exact same thing up here, I just switched that inequality. Now this is saying that I need to be going less than, and again this is just hypothetically speaking. My graph would look something like this then, less than, and there would be an overlap. So the reason that I point this out is because I don't want you to think that just because you have 2 parallel lines that you're always going to get no solution. It really depends on how you're shading. Because if I had taken this second problem here was the purple, and that would be saying that I need to shade less than, then there would be an overlap at the green. Actually, the entire green would be overlap. And this little split section wouldn't be the answer, but it would just be down here. So keep that in mind, that just because when you graph the first 2 lines, if they don't touch, that really only matters up here when they're equal signs. But down in the inequality section, you always need to remember to shade. The only other one I wanted to go over was 17. And again, we didn't really directly look at any of these in class, so I wanted to make sure we kind of got a chance. The first one, 17, well, that shouldn't be anything crazy. It's just, y-intercept is 3. My slope is 1, 1. My graph looks something like this. And then as far as shading goes, it says less than, so I want to be going less than. Okay, so that's my first graph. You do have the absolute values, so kind of using this as a nice review and constantly kind of reviewing the stuff we learned at the beginning of the year. Remember that you always find your vertex first. So what value could you plug in for x that would give you 0? And then what's on the outside? That's going to be my vertex. So start by graphing -2, -4, 1, 2, 3, 4. There's my vertex. Your slope is whatever's out in front. So I'm not spending too much time on this because, again, that was last unit, so I'm not really kind of trying to review that. So my graph's going to look something like this. It should take the shape of a V. And then I'm going to go ahead and color this. So here's my blue. And it says less than, so I want all the less than area. All right, that's all my less than area. And then as far as your answer goes, you are looking for the overlap in this case. So it's going to be kind of, here's blue and green, here's some more blue and green, and my answer is going to be the red. Now I do want to point out that if you're doing this whole color coordinating thing instead of like erasing your answers, maybe it'd be smart, just better safe than sorry if you have time, to actually tell me what your answer is. So a lot of times when I use colored pencils, I'll go like this, so kind of like a color key, saying that the blue and the green doesn't matter, but the red is my answer. So maybe on your test you might want to consider doing that to make sure it's very clear what you are saying your answer is. The next section was substitution. So you'll notice that as far as the whole two variables go, we have substitution, elimination, and graphing, but we did graphing on the first page. So kind of split them up a little and threw inequalities in the middle, but I just wanted to point that out. So substitution was the one where you're going to find the value of one variable and then plug it into the next one. Now, when we took the quiz on these ones a little while ago, a few of you guys, when you're looking at this problem, would say, oh, I'm going to solve for y. And then you do this whole bring x over, divide by 7. That's going to get really crazy. A lot of times with substitution, you'll notice that you see a variable all by itself. Or if I look over here, here's a variable all by itself. Here's a variable all by itself. Those are the ones that you want to solve for that given variable. So let's say for this one, I want to make this x equals, and then I'll bring the 7 over, so negative 7y plus 0. So that's what x equals. Or maybe for this one, you'll get a y equals, let's keep it negative y, because there's negative y, bring the 4x over, plus 20. Get rid of that negative sign, so y equals 4x minus 20. So it's just always a lot easier if you solve for that variable that's already alone. Makes your life a whole lot easier. Once you have that value done, make sure that when you substitute it in, you're substituting it into the other one. If you plug it back into the first one, it's not really going to tell you anything. It's just going to come out to be a true statement. So you have to make sure you plug it into the new one. So that's going to become 2 times x, but now x is negative 7y, minus 8y equals 22. That gives you negative 14 minus 8y equals 22. Negative 22y equals equals 22. Divide both sides, you get y equals negative 1. Perfect. And then you just need to figure out what x equals. And at this point you have some flexibility. You could plug it in here, or even over here, assuming that you did all that right. I'm going to go here just because it kind of looks easy. So I'm going to have x equals negative 7 times y. So x equals 7. Just do remember to write this as an x comma y form. The directions will say this on the test. So 7 comma negative 1. Done. That's my answer. And that's kind of what you would do with the other two, is kind of take that y equals and substitute it in for y. And then you would have a negative 2x minus 2 times kind of all that equals 10, and solve that. Elimination, we did a lot of elimination when you did the 3 variables. That's why it's kind of under this section, but I do want to kind of stress that these are kind of separate. You don't have to do these bottom ones by elimination. You kind of have the option on the test. I usually do elimination just because it seems like it works better for most people, but that's your choice. With 2 variables, elimination is usually a lot simpler, I guess you could say. So there's been a lot of questions about, we had some problems of elimination where the variables just conveniently lined up perfectly and canceled out perfectly. Actually, none of these do that. So this is one of those cases that a lot of you guys have been asking, like, oh, what do you do if, if it doesn't work out perfectly? So here's one of those cases. So if I look at, we could do number 6. I'm going to go ahead and do number 7, just because I think it's a little more difficult, in my opinion. If you look at 6, you could easily say, oh, I'll multiply this by 2, and then the y's cancel out. Or even over here, you could multiply this, by 2, and then the y's will cancel out. I guess that is technically true in 7 as well, because 7 you could cancel out the x's. You can cancel out whatever you'd like. So if I choose to go for the 6 and the 7, I would just have to figure out what's the greatest common or least common factor that they share. a lot of times it's going to end up being the multiple of each other. So if I wanted to get rid of the y, I would have to multiply this by 7 and this by 6. If you do that, if you kind of multiply them by each other, then they'll end up working out and canceling themselves out. One's negative, one's positive, that's what I'm looking for. But in this case, I think even here, it's maybe even easier to get rid of the 8 and the 16. So I'm going to go ahead and say, let's take this problem and multiply it by 2. That's going to become 16x minus 12y equals negative 40. Negative 16x plus 7y equals 30. I don't even have to change anything in that one. When I take 16 plus negative 16, they both go away, and that's going to give me negative 5y equals negative 10, y equals 2. How convenient. And then very similar to what we did up here, now it's just a matter of taking that y and plugging it in somewhere. I'm going to pick a smaller number. Let's go with this. So 8x minus 6 times y. But again, y is 2. And then go ahead and keep solving. 8x minus 12 equals 20. 8x equals 32. And x equals negative 1. My apologies. I actually see now, I looked at this and I thought this was a little strange. I lost the negative sign. And so here's one of those moments, one of those learning moments, that on your test, you're probably going to make the same mistake as I. You'll lose negative sign or something like that. I knew that this looked wrong mainly because when I plug it in back up here, if I plug in negative 1 and 2, it actually doesn't give me negative 20. So right there, I know that I probably did something wrong, and sure enough, I did. I lost the negative sign. So, and that happens, but that's why we always check our work. That way we can go back and figure out where we went wrong. So I lost the negative sign. If I add the 12 to the other side, that's actually going to make it negative 8. Then when I divide, that's how I get that negative 1. Okay. So again, one of those learning moments that you should be checking your answers, especially if you have time at the end of the test. If you finish your test like 10 minutes early, I would definitely recommend going back, plugging these in. You can do most of it on your fancy little calculators, Plug in negative 1, that gives you negative 8 minus, 12. So negative 8 minus 12 does give you negative 20. Check. Do it in this one. That would become 16 plus 14. Does 16 plus 14 give you 30? Yes. Check. So they don't have to be long checks, but if you want to be super confident, make sure you get 100 on the test. I'd probably go back and through those. Number 9 and 10, we kind of did a lot of these in class. So I'm not actually going to do these with you, but I might kind of talk through some of them. So this is my answer key that I'll put, or have posted to you guys. I did both of these pretty much through the same method of elimination. So when I'm looking at this first one here, I took equation 1 and equation 2, and I did elimination of one of them. So when I'm looking at equation 2, I did need to make this negative, so I went through and made it negative x, negative y, positive 4z, and a negative 12. So I made everything the opposite. Then I went through and eliminated the x's, and that gives me negative 6 minus y, gives me negative 7. 4 plus 4 gives me 8. Negative 12 plus a negative 12 gives me negative 24. This is one of those new equations. So I kind of starred that. You'll see that. Then in the second one, I line this up. So I have an x and a 2x. So I needed to change this to become a negative 2x, the opposite of it. So I multiplied it by negative 2. So the x times negative 2 gives me negative 2x. Negative 2, y. Over here, this would give me positive 8z. And then over here, that would give me a negative 24. So I took equation 2 and I rewrote it. And then I went ahead and combined it, these two right here. So the x's cancel out. Conveniently, the y's cancel out as well. And some of you may have been like, oh, I did something wrong. You didn't do anything wrong. It happens. And then over here, you have an 8z plus 5z gives you 13z. Since both the x and the y eliminated, I can go down here and just solve for z. So I got right off the bat, I didn't even have to do the whole two new equations thing, I just got z. And again, this is one of those moments where it's like, just work with what you're given. So in this one, I was given that I figured out that z equals 3. What am I going to do with it? Well, I can't plug it back into these bad boys because they have 3 variables. Over here, I got a new equation. This new equation only has a y and a z. Conveniently, I have a z. So let's plug that z in up here. That gives me negative 7y minus 24 equals negative 24. Keep solving this, and I get y equals 0. Once you have your z and you have your y, now you can go back up to any of these problems and solve for your final answer. So I believe that I went for this one, the first one. So I have x, okay, well I'm solving for x, minus 6y, but remember y is 0, so that pretty much is just 0, plus 4z, but I do have z as negative 3, so that becomes negative 12, equals negative 12. Solve that all the way through, you get x equals 0. That's okay. I got x equals 0, y equals 0. Not the end of the world. They are values. And your final answer would be 0, 0, negative 3. So make sure that you are kind of writing those out. And again, this is just another example. I won't talk through it, but you can kind of check it out in the answer key if you kind of get yourself stuck. A lot of times when I write these small pieces in between, it's because I usually rewrote something. So this one here, I multiplied it by 5. And that's going to give me 35, 15, and 45. And then I kind of combined it, these two. Same thing down here. So just, you can kind of do it any way you want. There's a lot of different ways to approach this, but that's how I did that one. The last section that I wanted to do were the word problems. The first 3 word problems should all be about the same idea. So let's just pick one at random. Let's say rental company here. We did one similar. It was a sprayer and a generator, I believe. And you rented the sprayer for 6 hours, the generator for 6. I think hopefully you remember that. A lot of these are very similar to what we've done in the past. So hopefully they look kind of familiar. This one says that Mr. Smith, for this much money, rents a dump truck and a snack truck. Both of them for 8 hours. So if I have a dump truck and a, let's just call it, I don't like picking S. My S's look like Z's. I don't know. Let's go with T. I can make a good T. Okay, so here's my dump truck, my snack truck. I rented this one for 8 hours, this one for 8 hours, and their sum cost is going to be $6.56. Then it says Mrs. William rents the same equipment, so she's going to get a dump truck and a snack truck. She rents the dump truck for 4 hours, and she rents the snack truck for 10 hours. So 10. Her sum total for renting these two would be $5.95. These are your 2 equations, and then very similar to what we did on the last 2 pages, you can choose substitution or elimination. If you're looking at the answer key later, you will notice that I chose to do elimination, so I multiplied this one by 5, this one by negative 4, gave me my new equations over here, elimination, solve for D, got D, plug it in, got the second variable. So again, just kind of doing that real quick. The only other one that I really want to make sure that I have a couple seconds to talk about, and then I'll let you go, is number 14. Number 14 is one of those ones, we talked about it in class. We talked about, I think it was a boat, or maybe it was a plane, I can't remember. But it was basically saying, maybe it was a plane, let's go with the plane, that you are flying one direction, and the first time you fly there, you're flying against the wind. So the wind is constantly fighting you, it's slowing you down. So when you're setting that up, you need it to be subtraction. Then on your way back, the wind is with you, so it is actually pushing you, it is actually speeding you up, and therefore that's kind of what's happening here. So whenever you're doing this, this one's saying that it's talking about a plane, traveling 720 feet. Our formula is always going to be distance equals, and again, you don't really need to know this formula, but distance equals speed times time. So when I'm looking at this, I don't really know what the speed is of this plane, but let's just call it P. But I do know how long I'm traveling for. So it took 4 hours, so that's going to be my T. So I need to have 4 times my speed. And then, of course, flying 2. This is flying, flying into the wind, which means the wind's actually slowing you down. So you need to be subtracting the wind. But again, the wind is a speed as well. So if I'm looking at finding the distance of this wind, I need to have the speed times time. Well, my time was 4 hours. And since this is a distance formula, speed times time, this should be giving you a distance. The distance they gave me was 720. Then it goes on to say that the trip back took 2 hours. So it was a shorter trip back, which is normally the case, especially when the wind is working with you. So here's the speed of the plane, still the same, except this time it only traveled for 2 hours. And the reason that it traveled for 2 hours is because instead of subtracting wind, I'm going to be adding wind. It's actually going to be making me faster. And again, the time there is 2 hours. Distance is the same. So a lot of these ones, whether it's a boat traveling upstream, downstream, a plane flying with the wind, against the wind, doesn't really matter. It's always going to be set up as 4 and 4, 2 and 2, or whatever numbers they give you. And then that speed and speed. The one that is the bigger value, so I could make up a story right now and say, oh, it took me 6 hours to fly and 4 hours to come back. The bigger number, the 6 hours, is always going to be subtraction. So the big number is always going to be subtraction. The smaller number, addition. And that kind of makes sense because if you're traveling for less time, that's probably because something's speeding you up. Versus if you travel for a longer time, maybe you hit traffic, who knows, but it's because something is slowing you down. And then once you have it set up, I think you can handle it from there, doing the whole substitution and elimination. I do want to point out, as far as points go on your test, make sure that any of your answers always have some type of word answer. And I kind of have this saying that if it's a word problem, it should have a word answer. So once, like, if you look at number 1, once I get my final answer, I say that the M&Ms were $8, the Twizzlers was $9.50. Having both that M&M Twizzler label plus the dollar sign, or the dump truck, this is money, so I need to have that money sign in there. The only one that really doesn't get a label would be number 13 because it's just talking about generic numbers, but I still found a way to say that this was my number 1, this was my number 2. And then, of course, the last one I have miles per hour because it is talking about speed and, miles and hours, so miles per hour. But other than that, like, if you were able to do this packet and maybe that was enough review for you, awesome. Do remember, dashed lines. Check out the answer key on Canvas. And other than that, I think this will be a good test for everyone, and I have complete faith that you will do really well. Good luck.